This is the stoichiometry of a precipitation reaction. That's just a lot of big words that say, hey, you're going to do a reaction and it's going to make a white solid. Not all precipitation reactions give you white solids, but this one will. You're going to start off with your exploration section. You got chemical equations. You studied those last week, so you should be really good with chemical equations. There's a review about moles in the periodic chart, but you already know that the number on the periodic chart, like in the case of carbon, that 12.011 is how many grams are in 1 mole of carbon. So that's going to be a good review. And then also last week talked about stoichiometry and how you can change from grams to moles, moles to grams. Like you already talked about that too. And then there's a quick comment about hydrates. Now, we had another lab that had hydrates in it. So this is just a reminder. You look up the mass of copper, the mass of sulfur, 4 times the mass of oxygen. And then you also add in 5 times the mass of water, which is 18.02. You can do all the elements individually if you want to do it that way also. But that's just make sure that you're including the H2O in the mass. So the reason this lab even brings up hydrates is because hydrates in some complexes are a lot more stable than their non-hydrated form, because there's a lot of chemicals out there that are what we call hygroscopic, which means that they absorb water. And so if we give you this form, it's just super stable and it has a long shelf life. So that obviously makes sense why it might be in your kits. So we are going to do a reaction with the hydrate form of copper sulfate, but the copper sulfate is what's doing the reaction. The waters are just there. They're just there. They're keeping things stable. Kind of like having, I don't know, something like some of that like silicone stuff in your, I don't know, in different bags of food to try to keep things stable. Or dry at least, I guess. The water doesn't keep it dry, but it just helps the compound be stable. Anyways. We are going to go to the experimentation section. In this section, the kind of main thing you need to make sure that you have on hand is some distilled water. You've needed it at other points in the lab, so you probably already have some. You just buy like a big one at the beginning of the semester and you're good to go. And then here is the actual reaction itself. So I got this different kind of format. I haven't updated everyone's labs to look like this, but I have this general information. Please note, 24 hours drying time, 24 hours drying time. It's one of those where you filter it just like with the separations lab. And then you had to let it dry because it was wet, because it just like dripped out. That's what it is. This lab is not an extremely long lab. It just has a little bit of math. Depending on how long it takes you to do the math is going to affect your time on the lab. Make sure that you also recognize that although you need to be, careful with the amount of distilled water, it doesn't have to be perfect. So measure the water in this lab, but don't stress out about it as best you can. Again, as always, digital balance, grams, and your scale needs to be recorded to 2 decimal places. Then I have this section. Here's just a heads up on the pictures, and all of these pictures have tabs at the bottom now, and they're just also going to be the ones you upload to the Dropbox, but they all have tabs. Note that you have 2 questions with calculations. You see that? Make sure those calculations show up in the lab pictures, in addition to the clearly labeled calculations for those other steps. And then here's a new kind of thing. This kind of gives you a preview. Those steps need help, but the actual help is way at the end. So I'm going to scroll on down. And so all the comments are kind of moved at the end. So here's some help on step 8 and comments, step 9, step 14. And then lastly, here's some little tips about the questions 2, 3, 4, and 5. And finally, a don't forget about the data tab at the bottom. All right, so let's just walk through the experiment. I'm going to do a quick scroll. All right, and then I'm going to make this section small, and I'm going to make my other section big. So make sure you're wearing your safety gloves and goggles, because that's always good practice. And go right on here. You're going to use a graduated cylinder. I'm going to actually make that wider so that you can read it for a second. So the third step, you're going to measure 25 milliliters DI water, and you're going to add it to each of the 200 milliliter beakers. So I got 2 beakers here, and I thought I had put in a graduated cylinder, but it looks like I didn't. So you've got like a little graduated cylinder, and it's got the little markings. So it wants 25 milliliters. So you're going to take your water, you're going to lift it up, pour it in, chug, chug, chug. So then your graduated cylinder, oops, my picture went with it. I'll just have to give it a new base. My graduate cylinder now has the 25 milliliters of water. So I'm going to take that. I'm going to take it over to one beaker. I'm going to pour it in one beaker. So now I've got like 25 milliliters of water here. Obviously, those proportions don't quite look right. And then I'm also going to repeat it again. I know it looks like I've got water in there, right? So once it's gone, bring it back up here. Give me some more water. So it's going to be filled up. And I'm going to pick it up and I'm going to put that in that section. So I'm going to have 2 beakers by the end of this step that has that water on it. All right, so now you've got, turn on the digital scale, plastic weigh boat. On the scale, tare it so it reads 0. And then you're going to use the metal spatula to put 1.50 grams. Try to get it real close to that. So we've got our scale. Import out. This is just a generic one. It's not necessarily going to be like that color. I know I was thinking it'd be a little bit more whitish, but that's the picture I could find. So that, you're going to put that in, and that's for the calcium chloride. Don't get your compounds mixed up. So this is the hydrate right here. This is the only hydrate in there. So you're going to weigh it out and make sure you notice you're doing it to 2 decimal places. All right, now you're going to add it to one of the beakers. I'm on step 6, containing the distilled water. You're going to submerge the weigh boat into the beaker to transfer all of it, if any residue remains, on the boat. So like you just don't want to lose any of it. You want it all in there. You're going to swirl the beaker until it's dissolved in the water. So notice you aren't going to have to like really stir it much. It should swirl in pretty well. There's one further on you need to like stir a little bit. So basically you're going to take that thing, you're going to take the amount that's on there, you're going to bring it up to this first beaker, and of course not with the scale. You're just going to take the paper. You're going to get it in there. So now it's good to go. And you know, you got some of that yellowish in here, even though it's not necessarily yellow. But as you keep stirring it, it's going to disappear because it's dissolved. It's still here. You know, you still have calcium chloride, but just like sugar or anything else dissolving water, it's just dissolved. All right, now the next step. You have to rinse that weigh boat and metal spatula because you're going to use it when you weigh out the next chemical. So now you're actually about to do a little bit of calculations because it doesn't tell you how much of the other thing is going to be sodium, Na2. I should use a different color. I'll use like gray. Na2CO3, that one. They don't tell you how much of that one. But that's the whole point of like the last week. This is what you do in a chemical lab. You weigh out one thing that you have a lot of, and then you do a calculation to figure out how much of, you know, the more expensive thing, whatever it is, and to figure out how much of that you're going to need. And you just do that calculation exactly how you're used to doing, where you take your grams of the one thing, you're going to turn it into moles, then you're going to go from moles to moles, and there's an equation I'll show you in just a second to help you do it. So it'll be like the moles, the calcium chloride hydrate. I'm combining multiple steps. They'll have you just like do the first step here, and then they have you do the next step, and then, but I'm kind of putting it all together just to remind you. And then finally you can get that into a gram amount. So this number here is what you're going to get in here. And you know, you're going to need like a normal number, not like 50, right? You're going to need like, I don't know, it'll be smallish. So once you get through all the math steps, and the math steps are going to be 8, some of 9, 10 is just tearing the scale, and then finally when you get to 11, that's when you're going to measure out the calculated amount. So whatever that number is, I didn't actually put a number, but whatever the number is that you calculate, that's what you pour on there. And then guess what? You put it in the other beaker. So here we go, putting it in there. Now this one is a little bit, it's not going to be black, but say it's black. So you got a little pile at the bottom. This one's going to need a little bit more stirring to dissolve. It'll dissolve, but you just have to kind of stir it up a bit. There you go. So now it's going to just look like just plain old water. There you go. So that's all good with the water. So now you have one thing that has that calcium, and then the other thing that has the Na2CO3. That's what we're going to do the reaction with. So notice this is just going to look like water, but it isn't. This is going to look just like water, but it isn't. All right, so we've done the stirring rod. Now, notice step 13. You're going to pour the NaCO3 into the beaker with the calcium chloride, And this is going to be like really fast. Like you're going to see something happen right away. So you're going to take this guy, you pick him up, pour him in, rinse. You might even use like a little water to make sure you rinse every little bit out. Pour it in, and then all of a sudden you're going to see this one is of course empty now because, you know, you poured it in the other one. So now this has a whole lot more in here, but even better, now you've got, you know, something really nice looking. I'm going to make it like be a big old pile of white powder all in there. Cool. So yay, you had a reaction. You're a chemist. And then the whole point after this is that you're going to you need to get this out from the water, and you're going to be using this funnel to do it. And you're going to use kind of the same procedure as you used for the separations lab. And then you got to let it dry. So it's kind of like the rest of what you're doing with this once you're done with your reaction. Notice that it says here on step 14, it says you can use this to determine what the theoretical amount of calcium carbonate is, because the white stuff is not the calcium chloride and it's not the Na2CO3. It's where you take those two things together and those two things together, and you have calcium carbonate. And if you look up your rules between the two of these, this is the one that's going to form a solid, and this is the one that's going to be dissolved in the water. You're not going to see that one, but this is the one that's going to be solid. So you have an amount here. That's going to be your actual amount because, hey, you did the experiment. That is what it is. But you're also going to do a calculation just like this before you used it to figure out how much of the NaCO3 you needed. But you're going to do it again to figure out how good your numbers were on your reaction. So then you'll do the exact same thing. Like I said, another calculation, copy, paste. Only this time it's going to turn it into calcium carbonate. I didn't label this one. This is the one where you were figuring out the other reactant. This one is the product. So this is the calculation that gives you the theoretical yield of that white product that's in there. And then finally, after you get all those calculations done, you're going to try to get it out. You're going to rinse this beaker. You're going to clean it up. Bubbles, yay, it's getting all rinsed out. Once you get all the way clean, then you're going to take, and this part, again, this is familiar because you've done this in another lab. You're going to take this, make sure you get I'm going to zoom it out. See how there's actually filter paper in there? They use that little triangle folding thing to make that happen. Your funnel doesn't have to look like that. You're going to put it in the top. You're going to take your stuff that's right here, and you're going to pour it in. And guess what? Your solid is going to be stuck in there. So there's your solid. You're going to have a little pile of solid there. And, oops, I've lost my beaker. I'm going to make my beaker come back. And then my beaker is going to be holding the liquid. And this liquid that's left, it's just what's drained out. It doesn't matter. What matters is that you've got some solid that can't get through because it's on the filter paper. So now, once it's dry, which will be like a day later, you're going to get your scale, and you're going to put that little pile of solid on there, and you're going to see how close you got. So, you know, if you did, this is not the correct calculation, but let's say that you calculated that you should have made 5 grams, but your scale says you made 4 grams, you know, you can figure out how good. You did 4 divided by 5, 4.0, 5.0 times 100%. And you can see, like, what kind of percent yield you had. So that's the experiment in a bit of a nutshell. I kind of went through the next few steps because it shows you how to fold the filter paper, which you already know how to do. It shows you about the funnel. You do want to, I did this kind of fast when I was pouring this. Make sure you do this slowly because there'll be a point at which it kind of gets kind of clogged and you'll try to pour some liquid in and it just won't drain very fast. Like, don't try to put it in fast. Do it kind of slowly. So just be patient about it. And again, you get to the very end, you calculate your mass, calculate your percent yield, watch your sig figs, and you're good to go. And don't forget, there's help on the steps of math at the bottom if you need it.